GOC. So today we will start GOC 2. So let's start with the reaction mechanism. We all know for a reaction to happen, we need a reactant first so that we can obtain a product. But in between it, we had a reaction intermediate, means the between product of reactant and product is known as reaction intermediate. For a reaction to become a product, we need a reagent or a solvent as a medium. Suppose we have taken a beaker. In it we put a reactant and a reagent, and a medium which is known as solvent is created. Solvent is basically the medium required, and hence we get the product. So solvent is a medium. Solvent is of two types. Okay. Solvent is of two types. First is polar solvents and second is non-polar solvents. For polar solvents, its mu is never equal to 0. For non-polar solvent, mu is always 0. About it we'll get to know later. Polar solvent is of two types: polar protic solvent (PPS), polar aprotic solvent (PAS). Now what is it? First, the example of non-polar solvents you have to learn some, that is benzene, CCl4, CS2, butane and hexane. Now solubility का principle क्या है? What is the principle for solubility? Like dissolve like, which means a polar compound dissolve in polar solvent only, and vice versa for non-polar solvents. That is, non-polar compound can dissolve in non-polar solvent only. Polar protic solvent. What is polar protic solvent? PPS. It is polar in nature, means solvent that is a medium which is polar protic in nature. Here it means this solvent will be polar in nature. It will contain acidic H in it, and hydrogen bond will also be present. Some examples are given: water, OH, phenyl alcohol, SH. These are some of the example important. Okay, you have to learn it by heart. Suppose we have taken a polar protic solvent medium in which we put NaOH as a reactant. What will happen is that NaOH is the reactant. Na will become positive, OH negative. From here, the PPS which we have taken is water. Water was in it, polar protic solvent, that is water as a solvent, and NaOH has been put in it as a reactant. Here what will happen, that the Na is positive and OH is negative. So when we H2O, when it becomes H plus and OH minus, H2O, the H part is positive and O part is negative. As Na is positive, it will attract the negative part towards it. Hence, oxygen will be towards and hydrogen will be away. Same in case of OH minus. Hydrogen, the positive part, will be towards and oxygen, the negative part, will be away. Note: PPS can dissolve cation as well as anion part of the reagent. This is the reagent and this is our water is our PPS. So water can dissolve the cation part also and the anion part also. Now let's talk about PAS, polar aprotic solvent. Polar aprotic solvent is also polar in nature, but here acidic H is not present. If acidic H is not present, hydrogen bond will also not be present. Some example of PAS is acetone or DMK, that is dimethyl ketone. DMSO, dimethyl sulfoxide, and DMF, dimethyl formide, and one more, that is dimethyl acetamide, DAM. Two more are there, that is CH3CN and tetrahydrofurane. These are some of the example of PAS. Now in this again, the reagent we have used is NaOH and the PAS we have used is dimethyl ketone. Okay, here what will happen? Na positive, OH negative, they will get separated. In Na positive, the cation part, that is, this will dissolve, but the anion part will not get dissolved due to steric hindrance. As this is a bulky group. This is a bulky group, hence it does not allow the anion to dissolve completely. Half it will dissolve, but completely it will not be dissolved because of the bulky group present. Here we have to note that polar aprotic solvent dissolves cation part of the reagent only. Reagent जैसे HCl, H is the electrophile and Cl is the neutrophile. So only the cation part will get dissolved. Now, what is electrophile? There we saw electrophile and neutrophile. In PAS, now we will see what is electrophile. Electron plus phile is electrophile. Phile means to love. Electrophile is the one which loves to take electron. Electrophile is an electron deficiency species which is attracted towards electron. Why it love electron? The thing which you do not have, you always want to have it, and hence you love it. But once you get it, you loses the desire to love it or to have it anymore. That's why it do not have electron, it is deficient of electron, hence it love to have electrons. Okay, it need electron, it love electron because it do not have electron, hence it is known as electrophile. Electrophile may be cation or an vacant orbital. Cation like Na plus, it have one electron in deficient, hence it want to have stability in its life, and to have that stability it will want electron so that it can get stabilized, hence it love electron. That's why it is known as electrophile. और अ वेकेंट ऑर्बिटल स्पीसीज, जिसका एक ऑर्बिट या वेकेंट हो, खाली हो, उसको भरेगा कोई तभी तो वो स्टेबल होगा. दैट्स वाई इट इज़ ऑल्सो एन इलेक्ट्रोफाइल. कैटायन का एग्जाम्पल जो इलेक्ट्रोफाइल है दिया हुआ है, यू हैव टू लर्न इट. आर प्लस में क्या क्या आता है? CH3, CH3CH2, NO2 प्लस, NO प्लस, SO3 plus H, SO3H plus, or this all are example of cation which are electrophile. Note: CH4, H3O plus, Na plus, K plus, Mg plus, these all cation of 1A and 2A do not work as electrophile because they have complete octet. ये सब जो है इनका octet complete रहता है. That's why they do not work as electrophiles. Okay? For example, हम लोग NH4 को ले लेते हैं. NH4 हमारा NH3 जिसके पास 3 रहता है, वो कोवैलेंट बॉन्ड बना करके हमारा NH4 बनता है. यहाँ पे प्लस साइन तो रहता है, लेकिन इसको ज़रूरत है क्या इलेक्ट्रोफाइल का, इलेक्ट्रॉन्स का? ये तो ऑलरेडी इसका ऑक्टेट कंप्लीट हो चुका है. Same way for all this. That's why it do not act as a electrophile. Now, neutral vacant orbitals. हम लोग कैटायन के बारे पढ़ लिए कि वो क्यों इलेक्ट्रोफाइल होता है. अब हम लोग वेकेंट ऑर्बिटल्स के बारे में जानते हैं. Why it is an electrophile, neutral vacant orbital. Examples दिया हुआ है. This is all, okay. All Lewis acid work as electrophile. ये सारा प्लस all Lewis acid works as electrophile because of the vacant orbital. Polar pi bond containing species, जिनके पास polar pi bond होता है वो भी हमारा electrophile जैसा एक्ट करता है. जैसे कि फॉर एग्ज़ाम्पल यहाँ पे हमारा ये pi bond प्रेजेंट है, एक पाई एक सिग्मा, एक पाई एक सिग्मा. हमारा जब ये अपना एक बॉन्ड, पाई बॉन्ड ऑक्सीजन को दे देगा तो कार्बन पे पॉजिटिव साइन आ जाएगा, मतलब कि ये डेफिशिएंट हो गया. दैट्स व्हाई इट इज़ एक्ट एज एन इलेक्ट्रोफाइल. सेम फॉर ऑल दिस. Neutrophile. Neutrophile, neutron plus phile. Phile already we know, to love. Neutron lovers are known as neutrophiles. Electron-rich species which attack on electron deficient center, which means that as a species जिनके पास खूब सारा इलेक्ट्रॉन हो वो क्या करेगा, जिनके पास ना हो उन पे जा कर के अटैक करेगा. जैसे कि हमारा Cl माइनस, इसके पास एक एक्स्ट्रा इलेक्ट्रॉन रहता है, ये क्या करेगा, Na प्लस जिसके पास इलेक्ट्रॉन कम है उसमें जा कर के अटैक करेगा. तो ये हमारा क्या NaCl बन जाएगा. तो ये हमारा क्या हुआ, ये Na हमारा इलेक्ट्रोफाइल हुआ, और Cl जो Na पे अटैक किया है वो हमारा क्या हुआ, न्यूट्रोफिल हुआ. दोनों मिल के क्या बनता है, NaCl. नाउ यू गॉट द मैकेनिज्म. न्यूट्रोफिल कैन बी लोन पेयर और नेगेटिव चार्ज स्पीसीज. न्यूट्रोफिल कौन कौन होते हैं, जिनके पास लोन पेयर होता है या फिर नेगेटिव चार्ज होता है. एग्जाम्पल एनाइन का एग्जाम्पल दिया हुआ है यहाँ पे, नेगेटिव चार्ज स्पीसीज। ये सारे एग्जाम्पल है। यू हैव गॉट द आइडिया वाई। ऑल न्यूट्रोफिल्स आर बेसिस बट ऑल बेसिस आर नॉट न्यूट्रोफिल। सारे बेसिस जो होते हैं वो न्यूट्रोफिल्स होते हैं, लेकिन सारे न्यूट्रोफिल्स जो सारे न्यूट्रोफिल जो होते हैं वो बेस होते हैं, लेकिन सारे बेसिस न्यूट्रोफिल्स नहीं होते हैं। नाउ विल सी वाई। ये हमारा OH है, ठीक है। ये हमारा CH3Cl है। ये दोनों मिलके हमारा ये बना। OH यहाँ पे हमारा न्यूट्रोफिल जैसा एक्ट कर रहा है, और CH3Cl जो है वो हमारा क्या बन रहा है, ये हमारा CH3 हमारा इलेक्ट्रोफाइल बन रहा है। ये दोनों रिएक्ट किया, हमारा रिएक्शन हमें मिल गया। तो यहाँ पे हमारा न्यूट्रोफाइल इलेक्ट्रोफाइल रिएक्शन हुआ है। ये बेस था, ये हमारा न्यूट्रोफिल जैसा एक्ट किया। ये भी हमारा बेस है, लेकिन ये हमारा न्यूट्रोफिल जैसा एक्ट नहीं करेगा, क्योंकि ये ऑक्सीजन के साथ एक्ट हो रहा है, और जब एसिड और बेस रिएक्ट करता है तो वाटर बनता है, ना कि इलेक्ट्रोफिल न्यूट्रोफिल का प्रोडक्ट, ठीक है। दैट्स व्हाई all neutrophil are bases but all bases are not neutrophile। यहाँ पे हमारा न्यूट्रोफाइल के बारे में अब हम लोग पढ़ेंगे। यहाँ पे हमारा लोन पेयर कंटेनिंग स्पीसीज के बारे दिया हुआ है। यू हैव टू लर्न ऑल दिस, यू हैव गॉट द आइडिया, द रीज़न वाई। एग्जाम्पल्स आर गिवन हियर। pi bond containing groups। From this we'll learn, okay, this is there, so let's study now. Pi bond, here the pi bond we are seeing is non-polar pi bond, there it was polar pi bond. You can see here CH, CH2 and a functional group. The double bond present, one is pi bond and one is sigma bond. This is the electron cloud here, electron cloud. Triple bond also electron cloud is present. Electrophile can easily attract at the electron cloud, okay. That's why it is a neutrophil, because of the electron cloud the electrophil will attract on it, hence this becomes a neutrophile. Example Br plus Cl minus, these are electrophile as well as neutrophile both. यहाँ पे हमारा एक और है लोन पेयर कंटेनिंग ग्रुप विच इज़ अ न्यूट्रोफाइल एंड अ वेकेंट ऑर्बिटल विच इज़ एन इलेक्ट्रोफाइल। एंड हेंस डन फॉर दिस क्लास। फॉर एनी डाउट पुट इट इन द कमेंट सेक्शन, एंड in next lecture we will discuss some of the questions related to this and we will proceed further. Thank you for watching this video. If you like the video, please like it.